In a world where triangles run amok, one theorem will keep its sides proportional. The side splitter theorem, the greatest, the most noteworthy, the most amazing of all theorems, states that if a side of a triangle is parallel to the base, and it intercepts the two other sides, it splits those sides into proportional pieces. Now, this is visible through the way that when line L intercepts triangle CAD and is perpendicular to the base, parallel to the base, we can see that Cx over xa will be equal to Cy over yt, which means that they're proportional to one another. So we can use this in one way to find side measurements. So if we were told that this entire side is 5, that this portion, that Cx is 3, then we can find out that this xa is 2. And now all we need is the length of side CT, and we can figure out the values of Cy and Yt. We can do this by plugging in Cx over xa is equal to Cy over Yt. So 3 over 2, which is going to be equal to 6 over 4, and 6 over 4 also adds to 10. So that's how it's used to find side lengths. And the greatest of all theorems must also have an application outside of this. And one of these ways is that it has a corollary. The corollary theorem works in a similar way. If you take 3 or more parallel lines and you cut 2 other lines that are not parallel to the original lines, then they cut the lines proportionally. And we can see line A and line B, and they intercept the 3, and they're intercepted by the 3 parallel lines. So between the 2 red dots are the points of intersection. So if the section between line L and X on line A is 5, and the whole length is 10, we get 5. Then it'll be the same thing, just like in the previous theorem with the triangle. If this is 15, this is going to be both 7.5, because 5 over 5 is 1, and 7.5 or 7.5 is also 1, and it adds 15, which is how it all wraps together, very similar to the triangle here. So, finally, it's very useful in constructions. In order to construct a trisection point, we would first start with this base blue line, which would be the line we would want to trisect, line segment rather, and we would draw another line at any angle, and then we would take a radius and we would cut 3 points into it so that we trisect that line. And due to the side splitter theorem and its corollary, we know that if we take this and we turn it into a triangle, and then we form two other parallel lines, that the distance between these lines will be proportionate. There's also a third line going through where the red line and the blue line meet, but it's not showing up. So we have between the 4 parallel lines, it's going to be the same proportion as this. Because this is a 1-to-1 proportion, which is congruent, then these 3 will be congruent, and we have just successfully trisected it. That's how it's using trisection. In real world, other than saving the world, this theorem can be used in many ways, but one that's particularly very useful uh, especially in spring, is when you're planting your garden, and you want all of your rows of plants to be the same distance from one another. We make sure we draw 3 parallel lines in our orchard or our garden, and we make sure that these 3 distances are the same, and therefore all plants on these lines will be the same distance from one another. So that is my theorem. I hope you liked it. I certainly loved it. It changed my life uh, for the better, and I will see you later, I guess.